Hi, I'm Sören, one of the co-founders of Terramate, the infrastructure as code development platform that helps platform teams and developers to deploy and manage cloud infrastructure with infrastructure as code tools such as Terraform, OpenTofu, and Terragrunt faster than ever before. Terramate adds powerful capabilities to any existing or new infrastructure as code projects. Environments allow to promote workloads in the infrastructure from development to production in minutes. Developers can self-serve even the most complex infrastructure, automation and orchestration workflows, detailed visibility and observability, as well as AI agents that help you overcome failed deployments or drift. Terramate is available on Terramate Cloud and comes with a generous free plan and can optionally be self-hosted on your own infrastructure. Let's explore those capabilities by looking at our platform. The dashboard in Terramate Cloud gives me an overview of how many infrastructure environments are deployed in my organization, how many of those are drifted, and how many of those are failed. You can also see that we show you a graph that shows how many deployments have occurred in the past 90 days. The DORA Metrics feature allows you to compare the development of the performance of your organization over time. For example, you can clearly see here that our change failure rate has changed from previously 27% to now 8.3%. Clear improvement. Next, let's look at how developer self-service works in Terramate by deploying some infrastructure. You can see that I have my cursor instance open here. I'm in a repository called Terramate Catalyst example, which you can find in our GitHub organization. And I have Terramate CLI installed here in my environment. Terramate CLI is a tool that developers use locally to manage different infrastructure environments, but it also runs in CI/CD to orchestrate and automate your IaC deployments. Next, I run the Terramate scaffold command, which allows me to choose from a catalog of bundles that platform teams configure to allow developers to deploy production-grade infrastructure without having any IaC knowledge. In my case, I want to deploy an ECS Fargate cluster, which comes with an VPC, an application load balancer, and the cluster itself. You can see the interface exposed to the developer here is very simple. It allows them to choose an environment. In my case, I want to say development. A name, I call this dev cluster. And a CIDR range, which I will default to 10.0.0.0.16, which is what the platform team pre-configured. This will create a YAML file for me that contains my configuration. After that, I can run the Terramate generate command. The generate command will create the different infrastructure as code stacks from my YAML configuration. You can see that Terramate created 3 stacks, one for the ALB, one for the cluster, and one for the VPC. This is important as it's considered a best practice to separate different infrastructure components and state to lower blast radius risk and fasten up CI/CD runtimes. So the platform team can bake this in, and the developers can use this to simple to use interfaces. To deploy those changes, create a pull request in GitHub. After opening up the pull request on GitHub, Terramate CLI will orchestrate Terraform or any other IaC tool in GitHub Actions to create preview for your changes. You can see resources and how they change, as well as what stacks have changed in the current pull request. To get a detailed overview of the changes, just navigate to Terramate Cloud. Here we can see changes on a per stack basis. If we look at the ALB, we see all resources, how they change. We can change from the rendered format to the ASCII plans, which are the raw Terraform plans, and we can also change to the logs. This is important because Terramate will heavily parallelize the deployment of your independent infrastructure stacks depending if they can run in parallel or not. In that case, it will stream all logs in the right order on a per stack basis. We can also explain all changes with AI to get an even better understanding of what has changed here without having to be Terraform experts. We can navigate through the different stacks, understand all changes in detail, review everything before we eventually go back to the pull request and approve as well as merge the pull request back to main, which will trigger a deployment. Deployments in Terramate means orchestrating commands such as Terraform or Tofu apply in your CI/CD. This typically happens when you merge changes from pull request back to the main branch. Since Terramate heavily parallelized the deployment of infrastructure stacks, we typically see pipelines that run up to 90% faster compared to running on specialized CI/CD platforms. That also means that with Terramate you can enjoy unlimited concurrency and parallelism. You can see here that the deployment just ran in GitHub Actions. To get insights, I can navigate to Terramate Cloud. In Terramate Cloud, I see the deployment that happened 24 minutes ago. I can also see that 3 stacks have been deployed within this deployment. Remember, each stack in Terramate is an isolated state file, so that means 3 Terraform applies. Let's look at the deployment of the VPC. We can see the plan that was meant to apply. We can also look at the logs for this specific stack. This is extremely helpful if something fails. And we get a health check. And health checks are basically post-deployment drift detection that help us to understand in case a resource drifts right after a successful or failed deployment. Also, can we summarize the plans again with AI here to provide better context for non-expert users that can't understand Terraform plans. If we navigate back to the overview of all deployments, we can filter by status. For example, we can look at previously failed deployments. A previously failed deployment means that either one or multiple stacks have failed to deploy. With Terramate, we can skip all previous successfully deployed stacks to only redeployed stacks that have failed. But first, let's try to understand the reason for this failure. We look at the stack here, we see the plan that was meant to apply. Now we can look at the logs and we can see there's actually a syntax error here that was returned by the provider. The health check helps us to understand if our plan was partially applied or not. With the stacks browser in Terramate Cloud, we can understand what infrastructure stacks are managed in what repositories, by what teams, and in which environments. For example, let's look at the AWS ALB dev cluster, which we have just deployed. You can see all metadata of a stack, all alerts, all resources that belong to a stack. For example, we can see here the AWS security group. Let's take a look at this resource. We can see the resource ID, the address, the name of the resource, the cloud account it belongs to, when it was created, when it was last updated, the stack it belongs to, and we see policy checks. Policy checks are pre-configured policy frameworks in Terramate Cloud, such as, for example, the CIS Center of Internet Security benchmarks. We can see that this security group has unrestricted ports. We can also see that 136 additional policies are passing. We can see all attributes of the resource, which is ideally for us when debugging. And we can see how this resource was last changed and by whom. Alerts in Terramate Cloud is a built-in incident management system that you can use to manage failed deployments and drift. Drift detection runs as scheduled workflows in your CI/CD and is fully configurable on a per stack environment and repository basis. Let's look into this in detail. For example, you can see here is an incident for a drift detected in a stack that is called repository Terramate Catalyst examples. Here's an example where we basically manage a GitHub repository with Terraform. We can see details about this drift, so the plan, explain this drift with AI. We can also see when this drift was detected, last updated, and to whom this drift is assigned. This works because Terramate automatically learns who is responsible for failed deployment in case of a failed deployment or who introduced the drift. Alerts seamlessly integrate with Slack and send notifications to individuals or group channels. Alerts are intelligent and will be closed automatically in case failed deployments or drift are resolved. We can use Terramate to deploy AI agents to help us fix failed deployments or drift. For example, we just looked at an alert that showed a drift in a stack that manages a GitHub repository. I opened up the repository in Cursor and connected it to the Terramate MCP server. Now I'm going to use the MCP server to understand the drift better and to eventually fix it. Is there any drift in this repo? Terramate will authenticate with your cloud account. It will also query your cloud account for drift that belongs to the current repository. Please update the settings in this repository to reconcile the drift. So now Terramate will try to understand the drift better and will eventually update your code, which is both Terramate code generation, if you use Terramate code generation, or native Terraform, in order to reconcile the drift. This is how easy you can deploy AI agents in Terramate to take care of drift or failed deployments. This was a quick tour of the major features in Terramate. There's much more to discover than what we were able to cover in this video. The best starting point for you to learn more about Terramate is the documentation at terramate.io/docs. To get started, please create a free cloud account at cloud.terramate.io. Onboarding existing projects to Terramate can be done with a single CLI command and without having to refactor existing code. And also, please don't hesitate to reach out if you have any questions. We also have a Discord community for you to get direct help by our team. Thanks for watching.